So in this class, we will see some problems related to matrices. So first we will define some properties of matrices like equality of two matrices. How two matrices are equal to each other. So let us consider two matrices, matrix A and matrix B, where matrix A is denoted by small aij and matrix B is denoted by bij. Here we see that all the rows of matrix A is equal to the number of rows in matrix B, and number of column in matrix A is equal to number of columns in matrix B. So two matrices A and B are said to be equal if and only if, this is the very important condition. Number one, they are of same order. That means the number of rows in the first matrix is equal to number of rows in the second matrix. That means the number of rows in both the matrices should be equal. The second is the number of columns in the both the matrix will be equal. This is very important property of equality of matrices. And the element in the corresponding positions are equals. Corresponding positions, the value of corresponding positions, that is aij is equal to bij for all I and j. So this is the equality of matrix for taking problems and discussing their above properties. Now we will start to solve some problems related to matrix. So first problem is to write the element A23 of 3 into 3 matrix, where A is denoted by Aij, whose element Aij are given by Aij is equal to I minus j mod divided by 2. So we have to find A23. That means if we compare with this into Aij, the value of I here is 2 and value of j is equal to 3. Therefore, A23 is equal to, using this result, we have 2 minus 3 mod divided by 2. 2 minus 3 is equal to minus of 1 divided by 2. Mod of minus 1 always positive quantity, so therefore 1 divided by 1, because minus of mod 1 is equal to 1. Okay. Now second problem is, if the matrix is denoted by this 3 into 2, aij is equal to 3i minus 2j, then find a. We have to construct the matrix. So first we have the matrix of order 3 into 3. That means we have 3 rows and 2 columns. So A is equal to, we can write A11, A12. There is only 2 columns but 3 rows. So A21, A22, A31, A32. This is the matrix formation of A having 3 rows and 2 columns. Now we have to find all the elements related to this. So A11 is equal to, using this result, 3 minus 2 square. That means 1. A12, 1 minus 4 square. That means minus 3 square, that is 9. A21, 6 minus 2 square, that is 4 square, is equal to 16. Now next is A22, 6 minus 4 square, 6 where 3 into 2, 6, 2 into 2, 4. 6 minus 2 is 2 square, that is 4. A31, 3 into 3 minus 2 into 1 square, that is 9 minus 2. 9 minus 2 is 7. 7 square is equal to 49. And last one is A32, that means 9 minus 4 square, that is 9 minus 5 is 5, 525. Therefore we have matrix A is equal to 1, 9, 16, 4, 49, 25. So this is the matrix or construction of matrix A with this result. So A is equal to here 1, 9 and 16, 4, 49, 25. Okay. Next is, this is on based on equality of matrix. So if x plus y 1, 2y 5 is equal to 7, 1, 4, 5, then find s. So here two matrices are equal. So therefore, as matrices are equal, therefore their corresponding elements will be equal. So here x plus y corresponding, that is first row first column, here 7. So we can write x plus y is equal to 7. Let this is equation number 1. And here 2y is equal to 4. So we write 2y is equal to 4. Therefore here y is equal to 4 minus 2, that is 2. So the value of y is equal to 2. Therefore x from equation 1, the value of x is equal to 7 minus y, that is 7 minus 2 is equal to 5. The fourth one is find the value of x plus y. We have to find the value of x and y individually, and then we have to add them together to find the desired result. So here also two matrices are equal, therefore x minus y should be equal to minus 1. So x minus y is equal to minus 1. This is equation number 1. Okay. Here 2y minus y. Okay. Now here 2x minus y is equal to 0. So 2x minus y is equal to 0. This is equation number 2. Now solving them. So subtracting 1 minus 2. So x minus 2 is equal to minus 1. 2x minus y is equal to 0 minus plus minus. This cancel out. 2x minus x is minus x minus 1. Therefore x is equal to 1. So from 1, y is equal to x plus 1 from equation 1. So therefore the value of this is 1 plus 1 is equal to 2. Now we have to find the value of x plus y. So this is 2 plus 1 is equal to 3. So 3 is the result of this equation. The next one is if a is equal to cos alpha minus sin alpha, cos alpha, then what value of alpha the A is identity matrix. So we know that what is the identity matrix. Identity matrix is the unit matrix where the diagonal elements are 1 and other elements are 0. So here the matrix is 2 into 2. So we have a unit matrix. Identity matrix is order of I2 is equal to 1 0 0 1. So According to question, cos alpha minus sin alpha, cos alpha, this should be equal to the value of identity matrix, that is 1 0 0 1. That means the order of two matrix should be equal, and this is the order of 2 of unit matrix. Now here, if comparing the coefficients, cos alpha is equal to 1. So here the cos alpha is equal to 1. So as we know that cos alpha is equal to the value of cos 0 degree. Therefore here alpha is equal to 0 degree. Okay. Now we can also find from this minus sin alpha is equal to 0, or sin alpha is equal to 0, or we know that sine 0 degree is equal to this, so alpha is equal to 0 degree. So now as we seen here that we can solve the different types of matrix problem as discussed in the lecture 1 and 2 very easily using the property. Now we are just finished the types of matrices and some problems related to the matrices. Now there are some problems to solve. So these are the questions for the revisions. The first question is for a 2 into 2 matrix, A is equal to Aij. Those elements are given by this. Aij is equal to I by j. Write the values of A12. So we have to find the value of A12. Now find the value of A if A minus B is equal and 2A plus C, 2A minus B, 3C plus D is equal to minus 1, 5, 0, 15, 13. So using the equality of matrix, we can easily solve this problem. Find the value of x and y and find the value of A, B, C, D from these equations. So these are 4 questions for revisions. In the next class, we will solve these problems and then start the operations of matrices. And in operation of matrices, we will see how two matrices can be added, subtracted, and further operations, scalar multiplications, two matrix multiplication, etc.